Hello, today I'm going to be going over my backyard bird classifier model. So this is a model that was trained on the pre-trained efficient net B0 model. It uses the ImageNet weights, and it's a very complex model that required lots of resources and time to be trained. And so by utilizing that and implementing transfer learning, we can train just one more layer at the end of the neural network to fine tune that onto our use case, which is bird identification. So this app here is a backyard bird classifier. So it's meant to be able to capture a lot more of the challenging difficulties that come with backyard bird images, such as blur or low light or cropping. So if you were to just take a photo of a bird with your phone camera, for example, you might not have the best quality or image resolution. And so this classifier is meant to, use those images. So we use image augmentation when we train it, such as, random cropping or blurring or zooms and stuff like that. So the data set we use is the 200 bird species data set. We didn't want to focus too much on the model actual accuracy and performance and complexity. So we actually just chose to do 10 of the most common bird species. So that's these supported species down here. So if we navigate over to our web app, this is the backyard bird classifier on Streamlit, and we can just use a demo image. So here it randomly selected the white-breasted nuthatch, and the model predicts 94% confidence on the white-breasted nuthatch. So very strong model because we were able to utilize a lot of those complex features that were trained on the pre-trained model, the efficient net model. So if we look down here at the augmentation viewer, we can visualize some of these augmentations that come during the training process that help with some of the accuracy in classification that we get in this model. So instead of just using very perfect high resolution spot on images, we manually augment all these images with blur or lighting or noise so that the model can then accurately classify something that's just taken with like a phone camera in your backyard. So that's what this model is good for. So we also have a robustness summary down here. So it runs a prediction on every single augmented image of what was uploaded, and then analyzes the confidence and if it's the same prediction as the overall one from the top. So, and then we have confidence drift. So this one is pretty straightforward, but we do have some more confusing species. So if we can find one of these sparrows in the demo images, these are random. So here we have a white-crowned sparrow. So the top prediction is a white-throated sparrow. So it's actually incorrect here, but the next one is the white-crowned sparrow at 27%. But it is interesting to see here when we see the augmentations that the low light image was classified as the white-crowned sparrow. So that one was classified correctly as what the demo image is. And then we look at our robustness summary. The low light image was not the same, but all of these different augmented images have very low confidence. So we see a large drift here and not a lot of confidence going on because this is the white-crowned sparrow versus the white-throated sparrow, or they're very similar species in terms of how they look. So here's a blue jay, and I actually like this image because it is a little bit blurry. So this is more on par with what you might take from a cell phone in your backyard. So, but it does predict it with high confidence. Blue jay augmentation, it gets all of these correct on all the different augmentations with cropping, low light, blur. So this is an example of a pretty robust class that's being predicted on. There is confidence drift when it comes to the Gaussian blur. It goes down to 40%, but that is one of the more challenging, augmentations that you can put. So overall, this is the app here. I hope that you enjoyed this quick hackathon presentation. Thank you very much.